So here we have a rate of change problem where an object is thrown into the air, and we're given this distance function in regards to time. And using this function, we need to find a velocity function, and we need to find the maximum height of the object. So starting with part A, it's pretty important to remember that velocity in regards to time is equal to the derivative of your distance function in regards to time. So in this case, we have our distance function up here, and we just need to find the derivative of this. So starting left to right, hundred's a constant, so we can just get rid of that. And then 72t is just going to be 72. And then the derivative of 24t squared is just going to be negative 48t. So now that we have our velocity function, we can use this to try and determine the maximum height of this object. So even though this is a velocity function, we know that when a ball is thrown in the air at its maximum height, the velocity of the ball is going to be equal to 0, because then that's when it's going to transition back down towards the ground. So in this case, we can equal this this velocity function to 0, and that will give us the time that it took for this ball to travel its max height. So we'll go ahead and do that. We'll start with part B. And then we have 72 minus 48t is equal to 0. And 48t is equal to 72. And t equals 1.5 seconds. So as I said before, that we know that this is the time it takes for the ball to travel its max height. So we can use this time and plug it into our original function here, because this is the function, this is our distance function, which essentially gives us the height that this ball is thrown. So we'll just go ahead and plug this 1.5 seconds into that original function. So we have S of t is equal to 100. And plugging our first time value in, minus 24 1.5 squared. And this gives us a value 154 feet. That's our final answer.